Good morning, sir. My name is Noraiman Naim Ibrahim from BMMMHS1 stroke 1. Before I start, I would love to introduce my group member, which is Muhammad Mustaqim bin Rosman Rizal, B0919103881, and Muhammad Sufiyan bin Mazlan, B0919100389. Okay, today we will talk about torsion on a steering wheel. So, what is torsion? Torsion is basically the stress due to torque. Many structures experience torque, for example, torque wrench and car shaft. Therefore, it is important to quantify the stress caused by torque to help us design safe structure. Torsion is the term used for the twisting of a structural member when it is acted upon by torque so that the rotation is produced about the longitudinal axis at the end of the members with respect to the other. In the field of solid mechanics, torsion is the twisting of an object due to applied torque. Torsion is expressed in either the Pascal and SI unit for Newton per meter square or in pound per square inch PSI, while torque is expressed in Newton meter or foot pound force.
Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Mustaqim Rosman Rizal, and I will present about steering force calculation. Okay, as we see here, the FPD diagram, we have Fx, Fy, braking torque, throttling torque, wheel speed, and vertical force reaction. Okay, the basic concept is that torque required to turn the wheel should be more than resisting torque by friction. Okay, force of friction on one wheel equal to mu times gravity times corner mass. That is 0.8 times by 9.81 times by 45 equal to 353.16 Newton. And then we see the input torque from the ground on one wheel that equal to force of friction times by perpendicular distance from contact edge to pin axis. Okay, that's it, 353.16 times by 0.12831 equal to 45.31 Newton meter. Okay, the torque will be equal to the lateral push from the tight rod. Okay. The torque due to lateral push from the tight rod is equal to force on tight rod times perpendicular distance between the outer tight rod point and to the pin axis. Okay. Torque due to lateral push equal to force on tight rod times with 0.0945 meter. Okay, box torque will be equal. Therefore, as the tight rod pushing the tire from one side and pulling it from another side, so total force on right is 479.47 times with 2, that equal with 958.94. Okay, then we see on the radius of pinion, that is 26.11 millimeter. We convert it to the meter, that is 0.0261 meter. Okay, top of pinion is 1000 times by 0.0261, that we get is 26.1 Newton meter. Okay, the torque on steering wheel equal to torque on pinion, that is 26.1 Newton meter. The radius of steering wheel is 0.30 meter. Okay, force applied by the driver to steer the wheel is equal to torque on steering wheel divided by radius of the steering wheel. That's it, 26.1 equal divide by 0.30, that we get 87 meter. Therefore, if the driver of a car is making a right turn, applying force of 87 Newton to the steering wheel at point A and B as shown below, the force have parallel line of action but opposite in direction. Okay. The relative moment created by these two forces is the moment negative 87 cos 30 times by 0.30 minus by 87 cos 30 times by 0.30, that equal to negative 162.34 Newton meter. But when we count by clockwise, we get the positive is 162.34 Newton meter. Okay, for the top is 26.1, radius 0.30 and 0.27, and the next is 30 Newton meter. Okay, for the J or the polar moment of inertia is equal to pi divided by 2 times its radius. Okay, that's it. Pi divided by 2 times 0.30 power of 4 minus by 0.27 power of 4, and we get 4.3756 times by 10 power of negative 3 megapascal. Okay, for the torsion is equal to TC divided by J. That's it, 26.1 times by 0.50 divided by 4.3756 times is negative power of negative 3. So we get 1789.47 Newton meter square. Okay. For the factor of safety, FOS is torque max divided by torque actual, that is 30 divided by 1789.47, then we get 0.0167. So that's it. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sufiyan bin Mazlan. ID matrix number B0919103889. So for the project assignment, I will talk about the discussion and the conclusion. For the discussion, torsional shear stress or torsional stress is the shear stress produced in the shaft due to the twisting. This twisting in the shaft is caused by the couple acting on it. The mechanism of the torque works as the moment of a twist structure. Based on this project, which is about a car, it will control by steering movement, and if the steering wheel steady, then the car will move in a linear direction. But when we are about to turn, we apply a force for the steering wheel which tend to turn the car in the desired direction. The steering wheel rotates along its axis depending upon the direction of the force applied. Conclusion. In conclusion, following the steering wheel movement examined, we can conclude that calculation and the approach of this project are based on the learning outcome of teaching, where we can apply our knowledge of how to calculate the torque, torsion the stress, and the maximum stress. We also learned how torsional shear stress or torsional stress is the shear stress produced in the shaft due to the twisting. This twisting in the shaft is caused by the couple acting on it. By using Hooke's law, we can relate this strain to the stress within. In conclude, the finding of our project is regarding the Hooke's law principle as shown. The maximum force on the steering wheel which tend to turn the car can be calculated or can be called their free body diagram shows how the steering wheel applied the moment and the force. So that's all from me. Thank you.